This is notes 2.2, tangent lines in the derivative. So in the prior notes, every time we saw that f of x plus h minus f of x over h, I always called this the definition of a derivative, okay? But one thing I did forget to mention is the limit part. Okay, so we know that the derivative is the slope of the tangent line, which is the instantaneous rate of change. Well, we know that the instantaneous rate of change is just the limit of the average rate of change. So that average rate of change formula that we kept seeing in notes 1, we will just take the limit as h approaches 0, and that will give us the definition of the derivative. Okay. Some proper notations. Okay, so off to the left are all different types of notations of the derivative. The most common one you're going to see is most likely the first two. Not to say you won't see the other ones, but these first two are the most common. Okay. So in the first example, it says use the limit process of the derivative to find the general formula dy dx, another way to write f prime of x, of the following function. So remember, we're using that f of x plus h minus f of x over h, the whole thing as the limit as h approaches 0. Okay, so that means I'm going to plug in x plus h anywhere I see x. So that's this first part here. And then I'm going to subtract f of x, which is this entire function here. And what I do is I try to simplify the numerator before I bring in that divide by h right here. Okay, this is okay. Best practice, especially for the AP exam, is just to make sure you're always just writing divide by h, divide by h, divide by h. So you don't forget to divide by h at the very end. Okay, when we do this, we get 4x plus 2h minus 3. But we know h is going to approach 0, so we're just left with 4x minus 3, which is the derivative of 2x squared minus 3x. Okay, another form of the derivative we could see is instead of x, we might see a. Or we might see what looks like that f of b minus f of a over b minus a, that slope type formula. Okay, well, for these type of problems, not only do they want you to find the derivative, but they want to plug in a value, okay? So if we go through here and we find the derivative, so here is we're finding f prime of 1. So I'm going to plug in 1 into this function here, and then I get 2. Then I'm going to find the derivative of the function, and I'm going to do that by using this function up here. This f of x minus f of a over x minus a. Okay, that's where they got this part. Well, in order to get rid of that radical, I'm going to multiply by the conjugate, then simplify. Once I simplify, I plug in my a equals 1 value everywhere into the function, and then I simplify. Okay. Just some quick things if you want to highlight these in your notes. Okay, next part is estimating a derivative of a function at a certain point. So that's still using this same function here, and then they give us the y equals 2 over x at x equals 3. Okay, notice how they plug in everything given to them. They get rid of these two fractions in the numerator, simplify everything, and then plug in 3 to get the slope of negative 2/9. Okay. Another way of doing this is just showing you that these two definitions give you the same answer. Okay. Now let's look at this graphically. So on this one, everything highlighted in blue is representing a length. Anything highlighted in red is representing a slope. So here it went through all these different things, and we went ahead and labeled them either length or slope. So anytime these were labeled length, these were a distance. Okay, so for example, f of a plus h minus f of a. Okay, that is the distance between these 2 points, okay? Versus all of these type of functions represents a derivative in some way, and we know the derivative is a slope. So all of these were rate of changes marked with that slope of that, the approximate slope of that function. Okay. Looking at it symbolically, it says, notice each of these different ones are going to fall into 3 different forms, okay? The 3 different forms would be this. It would either be the definition of the derivative, so that limit, okay, or the alternative form. So another limit, but notice instead of x, they have a, and then the limit as x approaches a of something that looks more like the slope formula from Algebra 1. So from all of these, if we notice that these are the definitions of the derivative, we can identify the function in each of them, okay? So for example, here, this was the limit as h approaches 0 of 1 over h natural log of 6 plus h over 6. Well, here we notice that this looks like this one right here, okay? So we know that the function most likely is just the natural log of x, that outside function here with the natural log, and our c value is the 6. Okay. Same with this one here. Our function here is the tangent of 2x, and this 2 plus h was plugged in to x. So that's how we found that this was just our initial function. And then our c value is 2 because remember, it's always a plus h or x plus h. Okay, and since this 2 is being added to h, then we know c is equal to 2.